This time, we are going to prove the limit of the difference of two functions is equal to the difference of their individual limits on a specific order. It states here that if the limit of f or f of x as x approaches to c is equal to L, and the limit of g or g of x as x approaches to c is equal to m, then the limit of their difference in that exact order, f minus g, as x approaches to c is equal to the difference of their limits in exact order. Take note that subtraction has no commutativity, so we need to really structure it in this manner. To prove this using the theorem, we need to come up with a existence of a delta for every epsilon, and then later on we're going to combine them and arrive at a situation declaring that the limit is really true. So we will have this form here of the proof. I'm not going to write here the definition itself, but let's start with the proof. Let's say epsilon be greater than 0. Okay, so by letting epsilon be greater than 0 as part of the proof, we need to show that there exists delta greater than 0 such that if the distance of x and c is greater than 0 but less than that said delta, and x is an element of A, then using the idea here for this to be true, the difference of the, what do you call this one? Sorry for that, let me rewrite this. F of x and g of x, okay, minus, you have the limit L minus m in that specific order is less than epsilon. This is what we are trying to show, and this is what we need to show. But first, we will ask for the existence of delta. In order for us to be guided with the possibility of the existence of delta, we need to have a short scratch work here, just for us to be able to see what is the correct illustration later on of epsilon and delta in terms of epsilon. So I take that with this form, f of x minus g of x minus L minus m, or the quantity. We can actually restructure this. We have your f of x minus L, and take note that as we take this is negative here, this is plus as we apply the negative here. So we are going to also take the negative sign for g of x, and this is still minus m. Noticeably that if we're going to distribute that, this will become same, plus m, and minus g of x here, and for minus L as well. So we are not actually changing the actual expression, we're just rearranging the terms. This is because we can apply here the triangle inequality, which tells us that if we have two quantities here subtracted under absolute value notation, we can separate them, f of x minus L, and we have here plus as well. That's for triangle inequality. We have a property for that. In short, for this, we just need to structure situations for this that will allow us to arrive to an epsilon, because that's the same here. So that would be our goal. And with that, probably you are thinking that we can just simply divide epsilon into 2. Okay? But later, let's talk about that later. So after this, just be guided with this form because we will return into that. Now, let's look into the assumptions. Since the limit of f of x as x approaches to c is equal to L as declared here, so we will have here then for any epsilon sub 1 greater than 0, there exists delta sub 1 greater than 0, such that if the distance of x and c is greater than 0 but less than that said delta sub 1, and x is an element of A, then we can now say that f of x minus L is less than epsilon sub 1. Okay? Epsilon sub 1 in this case because we have this form here. Okay? Now, look into this. This is already presented here. So we're almost there. What we just need to do is the other one. Also, the limit of g of x as x approaches to c, which is equal to m. Then, for any, let's say, epsilon sub 2 greater than 0, there exists delta sub 2 greater than 0, such that if the distance between x and c is greater than 0 but less than that said delta sub 2, and x is still an element of A, then we can structure that the difference of g of x and m is still less than epsilon sub 2. This is by the use of the definition of the limit for the declared individual limits here. We will be using that as we will combine them later, because this and this form are what we call this one expressed in our scratch work earlier, our goal. So from this, let us try to let epsilon sub 1 be epsilon over 2 and epsilon sub 2 be also epsilon over 2. Then you will have here, or yeah, let's use so that this form here, the absolute value of a difference of f of x and L, which is supposedly epsilon sub 1, is now less than epsilon over 2. And of course, the same thing will go with this as less than epsilon sub 2, now being assumed as epsilon over 2 as well. So for this, the next part here, since we were able to establish already identities for epsilon sub 1 and epsilon sub 2, which could also be computed or combined later, the thing we need here is the existence of delta. So we are going to assume here delta be equal to the minimum of delta sub 1 and delta sub 2. So whatever be the minimum of that, that's our delta. And with that, we have already proven an existence, because these two are existing based on the individual limits. So if they exist, the minimum of that also exists, which corresponds to our delta. So with that now, then, if the distance between x and c is greater than 0 but less than delta now, which is again the minimum between delta sub 1 and delta sub 2, we have now our f of x minus g of x minus L minus the quantity L minus m, which is this scratch work with this form by triangle inequality less than or equal to the distance between f of x and L plus g of x, distance of g of x and m. Take note, we have already representations about them earlier. So this is less than epsilon sub 1 plus epsilon sub 2, which is equal to epsilon over 2 plus epsilon over 2 equal to epsilon. Which means, hence, okay, hopefully I still have some spaces, f of x minus g of x, that quantity minus L, the quantity L minus m, is less than epsilon. So finally, we're able to return to this with the existence of delta using the ideas of two limits. Now, we can finally say, since epsilon greater than 0 is arbitrary, then the limit of the difference of two functions f and g as x approaches to c is equal to the difference of their individual limits in exact order as well. So we have proven this rule on the limit. So we will have to review some of this and duplicate the process in the next few forms. Thank you very much for watching.